Welcome back.
Another update on this 72 GT 750 Ducati frame that I've been fixing.
Pretty much over the hill.
Just got to finish welding it out. I've replaced the sections I was going to replace. If you recall last time I used a 74 frame. I put the motor in that frame into
My jig.
on the table, and I used the front engine mount and the swing arm pivot as a datum, and I made these. They're just some basically height gauges. So I set the motor up at a known distance, 144 millimeters from the center line of this mount to the top of my table, and then through the headstock with a bar I came down to the table. If we move around here, I ended up with a measurement. It says number 15 here,
And it was
what's it say on here?
A15
Plus 23 millimeters at 63.2 degrees. So that's on the bevel gauge onto that point. That gave me the point to go back to on this frame. Now it had extensive damage, and as I said last time, this front wheel, a bit hard to show, was actually beside the motor, I'd say, and it was a repair. So I pulled, I think it was just under 3 inches back into the wheelbase. We stretched the bike, and if we come around here, pretty sure I showed this last time as well. We're now straight down the center line. That's where I was, and it got me to the point that I could remove the material that was too damaged by the accident and by the repairs done in the distant past, and hence why it had never been put back on the road. So these rails are the original rails, and really I needed to leave them. Otherwise I would have had three replacement rails, and the two worst ones were the spine that was actually bowed in 2 directions, so it went down, up and back in, and was concertinaed here because with the heat that they put, and when they put the force backwards here, it squashed the pipe. So what I needed to do was I needed to pull this way to get the angle back into it that had been pushed back. So that's where we were. Now this is chromoly tubing. I believe I used 2mm wall, which is 80 thou, and I cut the original spine, and I've come back into the original position, and I've just replaced it with chromoly. Now it's TIG welded into position. Inside is a standard insert bung that you do for tube repairs, and if you look, it's actually easier to show. These have been replaced with chromoly as well. I'll explain that in a minute, but this here shows I've left these in. Let me just get a torch from here. We'll be able to see it a bit better. Let's have a look here.
If you see
There's the holes that I've drilled. Wrong torch. I've drilled multiple holes around the perimeter as plug welds down into another tube. So my general formula is basically at least 2 times diameter. So this is about 32 mil, so it would be 64 millimeters long, spread halfway between the joint. Now that is also not a solid bung. It is hollow on purpose because a hollow tube has more rigidity that way than solid. and the formula on that's normally a minimum of half diameter, so 32 becomes a 16-ish. You need at least a 16
hole up the center.
So I TIG weld the plugs down onto the plug welds down onto the plug, and then I do a TIG weld on the join. And what I've started to do, if you see here, I deliberately leave them down because the finish, to get the finish,
So nice.
you actually need to hand file the joint. In my experience, it's the only way to do the finishing work to
Stop the dig of
abrasive discs on grinders. Lineages as well. Lineages do a flat. Hand filing is the way to really make that look like you were never there. The silicon bronze, I do a TIG braze, and I put silicon bronze over my weld. It's generally just easier to use as a fill.
it's less
Less work with the hand file, and there's no difference to strength because the strength's actually in the design. Now, these down tubes were bent in an S shape and bent sideways, and then also collapsed by the repair where they've actually clamped clamps on to move it. And if you see up here, these are actually welds that I've put on. There were welds down here as well that I put on. I genuinely weld directly to the frame and then finish with a file when I take it off. These will get lapped back, and then I'll file finish, and then I'll just run emery paper and an orbital sander over it, and you'll never even tell I was there. There's actually less damage to the tubes by doing so, in my belief. So their clamps, to get enough force to move the frame around, they had collapsed them. There was also the heat inputs around this area and up in here where they had a lot of heat to try to get the frame back into position. My general rule of thumb is I use the least amount of heat input to get the job done. I really don't like overworking the material myself, but that's my personal belief. Now, the problem with these tubes is they're not a standard size. Well, it is a standard tube size. It's 1 3/16 from memory off the top of my head, but it is a very rare use size. So what I've actually done, so I've machined this out of a billet. These caps are out of 4140 high tensile as a billet piece. Very much like, if we come over here, all the dimensions are taken off the factory ones. So chrome moly is a high tensile steel tubing, and it's 4130. So I found I had to look around a bit for it, but finally my supplier grabbed me some 1 1/8" in a 3mm wall, which is a 120 wall 1 1/8 tubing, and I needed about 450, so I brought a meter of it. I stuck out of my lathe 500 aside, and I used a traveling steady because it's tube, and I managed to actually machine 2mm off diameter, which is 1mm off wall. So from a 3mm wall came down to a 2mm wall. So that's actually the 1 3/16 on a 80 thou wall, or 2mm wall. So the factory frame is mild steel, and it's a 2.4 wall, and 2mm wall on chrome moly far exceeds mild steel at 2.4. It really is quite surprising how small the wall is of race vehicles, especially 70s racing frames used in
England. Really
quite thin wall like bicycle tubing. But I digress. So because they were so misshapen, I decided to take them out. So I've actually sectioned the frame here, and I've added these pieces in, and I'm just in the process of welding out as much as I can. I just wanted to show you where all I was, because the next step will be to take the motor out and do the finishing work, and that will be just the end of it. Basically, it gets a lot of love with hand files, various. If we look over here, I have a drawer of air tools and grinders and all sorts of stuff, and well, I have a few hand files, and I'll basically just give the whole thing a fettle and away it goes. On a side note, I'm actually going to try, that's my GPZ drag bike, bought it from a lovely couple. They'd raced it pretty much unchanged for about 20 years. It's a fairly mild combo. I've basically just given it a birthday after I brought it. I rewired it, I changed the foot pegs. Let's just say they were a little bit shorter than me, and I don't actually fit on the bike. The bike is a standard length swing arm. It's a smaller tyre combo than came out on it. That's actually a 250 rear rim with a pretty narrow little tyre on it. But I made some new plates up. They're the factory rear sets they used. I decided to keep the
manual shift.
I just made an adjustable lever. I didn't quite know where I wanted my feet to sit, so I thought, well, I've got the time. When I'm giving it a birthday, I might as well make it so I can move it all around. It does have a 1-2 auto race shift box, so basically the 1-2 auto means 1 and 2 are pre-engaged in the gearbox, and as you change gear, it's already in second, and as the speed of the gears takes off, it spits first out. Really cool bits of kit, done with angle grinders. Not quite, but it's all done with changing the shifter drum. It's really quite clever the way the old blokes went about it. This one was done by Joe Marshall in the Brisbane, southeast Queensland area. He was the go-to bloke in Australian drag racing for doing these auto race style gearboxes. This is actually really cool. It's got one of his Sprague overruns, so if you seize a motor on a drag bike with a race gearbox, you always stand the chance of the back wheel still driving and back torquing the gearbox and braking the gearbox. So if that happens, it's a really cool Sprague setup that Joe had, not the only bloke, but he had developed his own version of, and it will just Sprague out and not destroy the gearbox. I've got a brand new, I burnt out two GPZ's Unitract 4-pole starter motors. It's a 1260cc Wiseco kitted motor at 12.5 to 1. So the starter motors didn't like it. Made it just a push button start. It's pretty much all ready to go, and hopefully in the next couple of weekends, Willow Bank Raceway has got test and tune, and I'm going to actually head it out. I was a little bit naughty and took it out on the driveway at the front of my place, and it rides beautifully. not exactly a fast bike. Their fastest time was a 990, but that's on a standard cam, standard valve. It's
Just a bit of fun.
and I'm looking forward to it. Anyway, apart from the general lots of other things that I'm behind on that I'm catching up on, I just thought I'd give you an update on where this Ducati is. I won't say I'll be sorry to see it go, but it's actually been fun. Catches.